Hello, so in this video I would like to show you some more basic steps that can be done in ArcGIS Pro. This includes basic queries, attribute queries and spatial queries, editing attributes, adding attribute data, and visualizing these data. And as well, we would like to try the topological overlays or topological overlay analysis. Okay, we will work with the same data as last time. So I will recreate a new map and I will add data of regions. So we have regions. Okay, and now we can check out the attributable. We can see that we have the population field and a name field. Well, here, let's say that we would like to visualize for every region some statistical data. So at first we have to bring the data into a GIS somehow, and this is done simply by adding a new field in the attribute table and typing the values in, or we can get a table, let's say in Excel, and then just join this table to our attribute table. This way is faster, easier, and fail-safer, because when you are typing attributes in a table, you can always make typos, and then this will affect the resulting data. But at first, I would like to show you the very basic steps for adding the data. Let's say that we would like to visualize number of sheep for every region. So at first, we have to create a new field. So in the attribute table, we click the add field. We write sheep. Here we press enter. Now we change the type of the field: short integer, long integer, float, double date, or text. We go for, let's say, long integer. Okay, and now number format will be numeric. Okay, so when we are done, here up in fields we have to click save. Now the field is added to our attribute table. Just take some time, I don't know why, but here we go, and here we have sheep. Okay, now we can start adding the data to the sheep field. I don't have these numbers, so I will just put in some imaginary. So double click and we just type in the numbers. Okay, so when we are done adding the data, we have to go to the edit pane, and there should be save. Here we go. Now we have the saved edits. So now our data saved. So now we can go to regions, appearance, symbology, unique values, and we can visualize sheep. Okay. And what if we would like to say how many sheep are per 1,000 people? So then we have to add a new field, say sheep 1,000, but be aware that there can be only 13 letters or something in the field name. Enter. Now this is going to be float and numeric. Okay, when we're done, we go save. And now we go to compute value. So sheep 1000, we go attributable, right click, calculate field, and calculate field management window will open here. So here we say region sheep, and here are different languages we can use. Let's stick with Python. And we say that the new value is equal to sheep. Then we have to divide it by population and then time it by 1000, so we get it per 1000 people. Okay, we can validate it. Expression is valid. We go for run. And now here we got the values. Okay, they are all imaginary values, but this should be it. And now I would like to show you how to join a new table to this attribute table. Also, I have prepared an Excel table showing newborn baby statistics for all the regions. So here we have newborns from single mothers, married, divorced, widowed, total average age of the mom, and the kids that are out of marriage in percentage, like percent of kids born out of marriage. Okay, but to be able to link it to the attribute table, we need to define that something that's called the primary key of the table, a number that is connecting these two tables together. Here in this table, we have the FID, feature ID. Let's say that we use these values for linking these two tables together. So now we have to search for this hometown, capital town Prague has number 2, so we have to fill it so it matches. Starocecký kraj is number 5, and we have to fill it this way. So when we have added all the values to the table, we just save it, and we go back to ArcGIS Pro. Here I would just to note that while joining the tables, sometimes they may appear an error or the fields that are joining are not visible, so we have to go back to Excel and modify all the fields to be numeric and sometimes to work around a little with it. So now we go to the table that's highlighted here, the table pane, and here are tools to work with the table like add, fields, delete, sort, the same that are here, calculate, summarize, and stuff, but we would like to use joins. Add join, and let's say layer or enable view regions. Input join field is FID, and the join table we have to add the table which should be listed here and is not. So let's see why it's not visible here. Okay, we just have to click the refresh button and the newborns are here. And we click the list one. And here we see that we would like to choose, oh gosh. There's a problem that I did not put it to the first line. So I have to put it to the first line, save it. And now we try it again. Add a new join. Regions, FID. Now we have all fields here listed, and we use the ID, and if we click run, so the values should be added to the layer, hopefully. Yeah, here we are. So you see, it was a very simple way and a very fast way how to transfer a lot of attributes to the table without making errors, because this table comes from our National Statistical Institute, so these data are true, well, or right, or without any problem. So now when we can try visualizing. So let's say now we can go to appearance, symbology, and let's say that we would like to see the single moms. See, single moms. Well, but we can visualize more attributes. Or there should be some. No, it's not there. Don't worry. We can now visualize any attributes we wanted. Single marriage, or total, or overage, case out of marriage. We can use the graduated symbols. It will show us where is the highest burial rate. Sorry, not burial rate, newborn rate. So let's say that we would like to say the total, and we can normalize it by the area or by the population. So we can see that in Prague is the lowest newborn rate in comparison to number of people. In this Ústecký region, we can see that is the highest newborn rate in comparison to the population. So here I've shown you how to add the attributes, which is good to know. Okay, and now let's move to the basic analytical functions. So here I will use single symbol, and I would like to just make the outline. I don't need the attribute table anymore, but I would like to add, let's say, roads. So if we have a road network, we can have a look in the attribute table. We have the road class, we have number of lanes. So now we can make basic attribute queries. In the map pane, we go to select by attributes. We are querying roads. We do use selection, and we add a class. We would like to set the road class of the number 1 class, and all roads of the first class are selected. If we would like to choose first class roads that have 2 lanes, then we just add a clause. And there is a Boolean operator and an OR. So we choose and lanes is equal to 2. And the number is reduced only to these roads that are the first class and they have 2 lanes. We can visualize it as well. We can go to appearance, symbology. Here we're gonna use unique values. I just clear all selected, and we would like to visualize it based on lanes, let's say. And we have to change the colors, so we should be able to see where are 1, 2, and 3 lanes. If we do the road classes, so it's gonna be very similar. Oh, come on. Yep. There we go. Okay, so that were the basic attribute queries, or we can query the regions. Select by attributes. Select me, please. Select me all regions. Select me all regions where the population is greater than this. Yeah, but this is what we can do in Excel as well. This attribute query is just like make filters in an Excel table. But now if we add forests, do a forest here. Oh no, not nice. We have forests. That is not nice. Let's stick with a simple green. Forests and let's say railways. And we would like to find all forests that are intersected by railway. This is a spatial query. So we do select by location. We would like to select forests that intersect railways. And see, all forests that are intersected by railways are selected. If we do this vice versa, and we would like to select all railways that do intersect forests, then almost all railways are selected, because even if they pass the forest in a small part, the whole railway is selected. In order to have only the small parts of railways that are in the only small roads that are intersecting the forest, just the small parts of these lines, we have to go to analysis, and here we have to use this spatial the topologic overlay analysis, and here we say intersect. The difference in between spatial queries like select by location and this topological overlay analysis is that a spatial query creates only a selection. This tool or this function, this geoprocessing tool, creates a brand new layer. So the input features is and the second layer that we use are the railways. We have to define the resulting output we can put in the database, in the first tab database. Let's call it railways in forests. And we go run. And we have the new layer, railways in forests. You can see that only the parts that are in forests are created as a new layer, as a new feature layer. Okay, and now if we want to make a new some statistics about this new layer, like what's the total length of these features, we go to Attributable, and because these data are stored in database, the shape length is available and is updated, because here you can see the original length of the line, but only part of it is passing through the forest, so the updated part is in the database is dynamically updated. So we go right click, and here we have statistics, and graph is created, and here we have the sum. That is the sum of railways and forests in meters. So far we know how many kilometers of fences should be used to avoid the animals crossing the railways. Okay, so this was a very simple topological overlay analysis showing us the amount of the length of railway passing through the forests. And let's say that we would like to see the total area of forests that are within Ústí nad Labem region, this region. Well, if we use this select by location analysis, then we would like to use forests that intersect regions, and this region is selected. Then again, forests that are intersecting just in this tiny little bit are selected as well, which is not desired, right? But if we have selected, or if you can do it again, just click select the Ústí region, and we go right click, data, export features, and we call it Ústí region. Then just the Ústí region is created as a new feature. Now we can use the analysis like intersect, or better is to use a clip analysis. If we use the clip analysis, then the forests are clipped by the region. So forest clip feature by the Ústí region, and it's called forest clip, forest Ústí region, and like this can be clipped roads and all other features that we would like to. You see that we have the features only in this region. Okay, but what if we are interested in having the values or the area of forests for every single region? We could do it region by region, which is quite annoying. but we can use the regions. If we have a look into the attribute table, then we have the name of them, right? And if we do the intersect, and we do the intersect analysis, then all attributes are transferred. So we do intersect forests and regions. We say forests regions, and we have a new layer, forest regions, and if we have a look in this, then we have a shape area of each forest and the region name, right? And now we can just do summarize. We create a new table. We can call it forests regions statistics, and field and then we use the shape area. We compute a sum based on the regions. Now let's see what's going to happen, because it's the first time I'm using this function in ArcGIS Pro. There's a lot of data, so we have to wait. So now it should be done. So now here we have the table, and here we can see that every region has the sum of forests of the polygons and the total sum in hectares, which is great. So now we know how many forests are in each region. And that's all for this video. I hope you did enjoy it, and we will continue next time digitizing data and doing some more analysis. Thank you for watching.